Hello everyone, welcome back. This is Mr. Hussein. What's up? So in today's video, I want us to have an overview of a topic that is known as vector analysis. Alright, let's get to it. Now, every time you look at vector analysis, you are trying to analyze or understand what vectors are. By definition, we know that vectors are regarded to be quantities that will have both the magnitude, of which the magnitude is referred to as the size, and the direction. The direction is what is known as theta. Now, once you understand the definition of vectors, you have to know that we have several examples of vectors. Examples include things or quantities to say, such as velocity. We have force. We have other quantities like a jerk or acceleration. Could name others like impulse. Now even things like angular motion, which could be the angular velocity of an object. This is just to name a few. Now with this in mind, we can dive into some aspects that are needed to be understood under vector analysis. So in certain courses such as PHY and static engineering, it is important for one to know how to understand or come about in solving vector analysis problems. So, to begin with, I would like us to look at how we could resolve a single vector into its components. So, the first objective is simply just resolving a single vector. Now, every time we're resolving a single vector into its components, we have to take in consideration of the type of dimension we're focusing on. In our first aspect, we'll look at 2D, which is in 2 dimensions. When we say 2 dimension, our focus is simply the I hat and the j hat. When we say the I hat, we're talking about the x component, and we talk about the j hat, we're talking about the y component. So trying to see how a vector can be broken down into these components. Alright, so basically with a little bit of practice, I guess you will understand how to go about doing this. So let's look at some examples. Say we've been taught to resolve the following. So we have a graphical representation. This is the y-axis, which is the j hat, and this is the x-axis, which is the I hat. So provided that you have a vector in that manner, this vector can be a force, velocity, could be displacement, or even a wave vector. But in our example, we'll just use common vectors such as a force vector. So the force vector has a magnitude of 12 newtons, and say it has been given at an angle of, just give it to be 56 degrees. So now you need to know your reference point. The origin mostly is regarded to be the reference point, so you can put any support here of your interest. In most cases you find supports like a pin support. You get to understand what these supports really are. But for now, let's just say a pin support. Now, in order for us to resolve this given vector into its components, we have to know the movement we'll use in order to reach that particular point. Let me just change the color to red. So we know that this point here is called the tail of the vector, and that point there is called the head of the vector. So our objective is to move from the tail going to the head. Now you can't really move directly from the tail going straight up to the head like that. You have to move in a diverse way. You have to move in the components of the x and the components of the y. Don't let the j and the I confuse you. Remember, the j is the y and the I is the x. So you have to move in the direction where you have enough information. You can't move in this direction, then go the other way, because you don't really have anything there. Rather, you move in a different way. So you will go in this direction, which is in the positive I, which is the positive x. Then you move in the other direction, which is the positive j, which is the y. Now, one thing you should know is that the angle you have, which is in this case is 56 degrees, will always point in the component that will have what? The trig ratio, which is what? Sine. Therefore, wherever the angle points, that's where you will have your sine what? Theta. Let's be mindful about that. So, in our case, you will get your vector f, give a direction in that manner, and begin your movement. So you're moving in the positive I. So remember, it is always the size, then trig ratio, then the angle, then the x or y. So this is the format we follow. So in the first movement is in the x or the I component. So I'll move the magnitude, which is the size, so it will be in the positive 12. Now this direction doesn't really have where the angle is being pointed, so this will be cos, so it will be 12 cos, the angle which is theta, and the angle I have is 56 degrees. Then moving in the positive y, which is the j component, you have plus 12, since in the j that's where the angle is pointing, so that's where you have your sine. So 12 sine 56 degrees. Remember, this is in your I, and this will be in your j. After that, all you have to do is to compute this. Once you compute, you have some values, which will be, so you simply just get your calculator and you punch these values. You say 12 times cos 56, and you get something like 6.710314, just to mention some few values in the I. Plus you do the same thing, you say 12 times sine 56, and you get something like 9.94845087 in the j. So all you have to do is now round off these values. So you have 6, so I round off to 2 decimal places, so I have 6.71 in the hi-hat plus 9.95 in the j direction. So these are the components that satisfy your vector. You can also have other representations, such as example 2, where you have simply the same scenario. Say you have a coordinate system like that. You have your y coordinate, then you have your x coordinate like that. So your vector is somewhere there, and let's say this vector is a force vector, which is say 12 newtons. So your direction is somewhere there. So provided the direction is somewhere there, which is something like 34 degrees, like that, it will be easy for you to decompose this particular vector into its components. So you can create this point to be your pin support, like that. So since your vector is going in that direction, you have to move in the direction where you know you have more values. So I will move in the y-axis, then go in my what? X-axis. So my first vector will be, I move in my y-axis, which is in the positive j direction, and that will be 12. Since in my j direction, that's not really where the angle is pointing, so I'll have my cos. So I'll say 12 cos 34 degrees in the j hat. Then I'll move in my positive x direction like that. Since my angle is pointing in the positive x, then in my high hat, that's where I'll have what? My sine. So I say plus 12 sine 34 degrees in the I hat. If you compute this, you will get your values. That will be 9.48450871 in the j. Then you have 6.71031.484 in the I. If you round off these to 2 decimal places, your components will simply be 9.95 in the j direction plus 6.71 in the I direction. These two are the components that satisfies your vector. Example number 3. Suppose you have it this way. We know this is the x and this is the y. So let's say your vector is moving in that direction. Say that maybe this vector is some velocity of magnitude 24 meters per second. So let's say the direction is 56 degrees and you want to resolve this into its components. So you advise mostly that every time you're having these lessons that you could pause the question and try to resolve on your own and then compare with what I'll find in the end. Remember, in the first place though, always whenever you begin a topic, it might be a bit hard, but with some practice you'll get a hang of it. So try even though you have doubts. You never know. You might just get it right. So let's resolve this into its components. We know that this is our datum, or we can call it a reference point. You can put a pin support there, like that. So we're trying to find the components of this vector. So I'll move in the direction where I have more information. So I'm having more information in this direction. So I'll move in the negative x, so which means this is a negative I direction. Then I'll move in my positive y, which means this will be in the positive j direction. So in this case, you'll find that in the j direction, that's why you have your sine, because that's where theta is pointing. So v vector, I'll move in the negative I direction, so it will be negative 24. Now in the I direction, I don't really have the angle pointing there, so I have my cos 56 degrees in the I hat. Then I say plus 24 because it's positive in the j, as you can see, positive 24 sine 56 degrees in the j. All we have to do is to compute this with our calculators, and once we compute, we get something like minus 13.42062968 in the I, plus 19, sorry, let me write that clearly for you, then that'll be plus 19.89690174 in the j. So the vector v will now be rounded off to 2 decimal places. We'll have minus 13.42 in the I plus 19. Remember, if we're rounding off to 2 decimal places, if the third number is equal to 5, we get a 5, we get a 1 and add to the second number. And once we add that value there to 9, we get 10, so that will be 0 plus the 1 on the 8, and that will have 19.90, like that. That will be in the j. So these two are the components of the velocity of magnitude 24 in the direction 56 degrees, which will be minus 13.42 in the I, which is in the x, plus 19.90 in the j. Alright, say you have something like this now. Say you have your support like that. you have your y and your x. You have your force vector of 12 newtons. Say you have an angle of 34. You can pause the video and attempt to do it on your own. Alright, remember, reference point, create a pin there. This pin just shows you that this vector is being supported by it. So I'll move in the positive j, then I'll move in the negative I direction. So this implies that the force vector F is equal to, remember the format, magnitude, then trig ratio, which could be sine or cos, then theta, and then the component it's in, which could be the I or the j. So you get the magnitude, which is 12, positive that is. So in the j component, that's not what we're going to have the sine, we're going to have the cos in the j component. So 12 cos, 34 degrees, that's in the j, then minus 12 sine 34 degrees in the I. Now the arrangement of which one between the two should start first, either the j or the I, doesn't really matter. J can start first or the I can start. Either way, the magnitude will still come out the same. So if you compute this, you will get 9.94 8450 871 in the j minus 6.71 031 48 in the I. This will be rounded off to decimal places. You have 9.95 in the j minus 6.71 in the I. And these are the components of your force vector. Example number 5. Suppose you have something like this. Say this is your negative y and your x. So let's say the vector is in that manner. Set a velocity of 24 meters per second. The direction is somewhere there. That's 34 degrees. But let's try to resolve this. So remember, you put the support there on your datum or your reference, as others would prefer, then try to resolve it. So I'll move in my negative j, then go in my negative I. So this will be v vector being equal to the magnitude, which is 24. Since it's in the negative, so it's a minus 24. In the j, I'll have cos 34 degrees. That is in the j. Then I have minus 24 sine 34 degrees in the I. Then v vector is equivalent to, so we'll have something which is minus 19.8969 in the j minus 13.4206 in the I. Therefore, the final rounding off will be minus 19.90 in the j minus 13.42 in the I. So that's how you find your value. Well, the last question, which should be 7 if I'm not mistaken now, 6. Alright, so the last question will be, suppose it's in this manner. You have your force vector of 12 newtons. And then your direction, you know, this is your y, and that's your x. So say you have 34 degrees there. Alright, you can pause the video and attempt to do it. Alright, let's continue. So you create a datum. I put my pin support there, like that. Then I know I'll move in my negative y, which is in a negative j hat, then I'll go in my positive x, which will be my positive I hat. So my force vector will be equal to the magnitude, which is 12, so I'm starting with the j, so I'll say minus 12 in the j. I'm having my cos 34 degrees, that is in the j. Then I'm having a positive in the I, so I have plus 12. So in the I, that's why I'm having the sine because of the angle, so I have 12 sine 34 degrees, that is in the I. So if I compute these, I know I will have minus 9.948450871, that's in the j. Then I have plus 6.71031, then 48, and other values, but let me just end here in the I. Then round off to 2 decimal places, I have minus 9.95 in the j, plus 6.71 in the I, and these are your components. Alright, so this is actually how you go about resolving a given vector into its components, that is in 2 dimensions. Remember, in 2 dimensions, we're just looking at the x and y component. For the x, we use I hat, and for y, we use j hat. You get used to these notations with time. Remember, small progress is better than no progress. My name is Mr. Hussein Mwasabu. If you have any questions relating to this, you can always reach me on WhatsApp on the contact 077 149 5252. And remember to strategize before you become a statistic, and it's try and push for that A+.